And we're rolling, guys. Here we go.
We're rolling.
Good morning and welcome to our debate here on the IPC Connected Factory Initiative. Since the inaugural meeting here at APEX a year ago, there's been major strides made with the Committee on Machine-to-Machine Communication. I'm joined by a distinguished panel of people who are at the rock face in this particular topic. To my extreme right, we have Dan Gamota from Jabil. Welcome. And to his left, we have Oren Manor from Mentor Graphics. And of course, we have the chairman of the committee next to me, Jason Spera from Aegis. Welcome, gentlemen. So I'm going to dive right in with the first of our questions. I'll start with you, Jason. Can you give us a current update on the status of the standard?
Sure. When we last spoke, we had the committee had basically done a lot of the block and tackle work of the name, which is CFX, the committee, the charter, and all of that business. We had very productive meetings. These gentlemen participated in Chicago and thereafter. Mm-hmm. And basically, at this point, any standard for inter-machine communication and system-to-system communication for the industry has to have three elements. There's the transport, how you move the data around. Yep. There's how you're going to encode it. It's going to be an XML, JSON, what have you. And then the data content, which is what most people think of, is what would a given machine or device emit and exchange as data. At this point, the committee is developing comparatives on the transports. There have been proposals. In fact, one was actually technically adopted, but because true consensus is so important, it was decided that we would continue the analysis on that side. Okay. So that's ongoing, but I think approaching completion. And on the content side, something exciting has actually happened. We had an unusual unanimity on a concept that, as best we know, has never been attempted before on how to approach the content. Okay. And to try to put it most simply, in the past, data standards, of which there have been many, look at data content as, okay, you look at this genre of machine, pick and place an oven, what have you. And then a group defines the data types and content that type of machine will emit. Mm-hmm. That's one way of doing it, and it's the traditional way. Another way that reflects more what's actually happening with devices and machines is what I would call capability-based. Because if you take a modern stencil printer, for just an example, if you look at the modern ones, they may have an SPI head in them, right, which in itself is actually like another machine. Mm-hmm. And then they have a conveyor in them, another type of machine. They have an inboard barcode scanner maybe, yet another machine. And then the storage of the raw materials and the tooling could be considered a storage system. Yep. So it's actually a hybrid of different capabilities. So extend that now. If you do it by machine type, now you have the stencil printer group coming up with that, and they have to put SPI-related data in their standard. But the SPI vendors are also putting that data in their standard, so now you have this redundancy and problem in that way. The other approach, if I can mention one other problem, discrete manufacturing post-SMT is obviously on everybody's mind. Yep. It's not just the board anymore, it's building the entire product. In that space in the factories, there are often custom, completely unique machines. Mm-hmm. Integrators built them. 15 PLCs on them, 3D printers, things of this nature. That iteration of the machine will never occur again. So what happens if you go machine type centric? You have to then go to a committee for a machine that will never exist again for a data content spec. It makes no sense. It's going to be expensive, yeah. It could never be sustained. Right. But if you do it by the constituent capability parts of that machine, you can do it. So you take, okay, this is the content standard for a unit, arm, robot, the conveyor, and so forth. You can actually, there was a term came up in the meeting I think was great, it's like a Lego block approach to a data content spec, where all the lowest level of capabilities are granularly defined, and you can assemble them into a schema for a given type of machine. Right. And that actually was, we're going forward with a formal proposal on that immediately. And I personally, from a software perspective, I find it very exciting, because it's actually conceptually and implementation-wise a lot easier to do. Right, right. Sounds like a very structured and good approach to the data. But there's going to be obviously quite a big library of different capabilities that you're going to have to build in. But
definitely a very interesting approach. So, nothing that you can formally announce here. I mean, when are we actually going to start to see the first iteration of CFX?
The hope is that within 6 months, which would put us maybe July or August, there would actually be a draft standard that, while it might not go to the absolute level of granularity for every single type of capability, it would be a usable protocol at that point.
Okay. CFX, of course, standing for
Connected Factory Exchange.
Connected Factory Exchange.
And the committee itself is the Connected Factory Initiative,
right.
2-17.
Right, okay. How are you going to support it? I mean, who's going to, once you develop this standard, yes, it puts a protocol in place. Who's going to, but things change, things need updated. I mean, a lot of people were concerned with the previous CAMEX interface, and they felt that IPC didn't really support them properly on that. How can we be confident that IPC is going to do the right thing on this one?
I could speak to some of the past problems with protocols. One is if it's not free and open, adoption becomes a problem. In prior standards like CAMEX, the broker technology, the transport, was actually defined in the standard, and it was unique to the IPC. In CFX, whatever data transport is chosen, it will be open and free and standardized. So you will not be building a broker to the IPC spec. You'll be using for example, the data that moves our instant messages around goes through brokers that are used globally. Like 87% of the IoT traffic goes through a particular type of broker. So there is no maintenance of that because it's actually being used globally and it simply works. And that's actually great for time to implementation because we're simply connecting to that which already exists. So that maintenance is one aspect that I think that our approach is going to take care of. But I think you might have verged into how will the data content evolve. One of the problems in the past was you had to go to the committee to get extensions. That, in our Chicago meeting, was deemed, it was very unpopular, is a way of putting it, right. With the machine vendors for obvious reasons. And the schema that's being proposed actually allows proprietary extensions to occur that do not disturb the core data structure.
Right.
Because all the machine vendors wanted to have certain elements of data that they believe are specific to their IP, that they want to be able to provide to customers in the market, but they don't want it built into the standard, and it does accommodate that. There are ways of doing it with data structures now that are really quite elegant. Okay, so people have got, say, printers and pick-and-place machines, for example, that are communicating internally using their own protocols. A line-level protocol, right? Their own, which is proprietary. Yes, they'll be able to keep that and still connect to the CFX. The charter of the initiative actually allows multiple transports. There'll be a plug-and-play transport, which means if you buy any machine with CFX on it, you will know it will at least talk to that transport, bare minimum. But the charter, it was important to the committee that the charter allow for any number of transports. Now, you mentioned just earlier, it's just going to be based on XML? No, it will be probably XML or JSON is where the arguments are filtering out. It's yet to be decided, actually. Dan, if I could turn to you for a moment as a tier one manufacturer, what are you using at the moment, and do you think this is something that Jabil will adopt or participate in?
Yes, we are active members of different standards groups. If you look across Jabil, we have 5 different divisions. Each division is focused on a different market, and the equipment sets are completely different. So we have quite a bit of PCBA equipment. We have some semiconductor equipment. We have CNC machines. We also have machines that are used for water purification, photovoltaics. So we have such a diversity of equipment sets. We're looking for something that possibly could service all those different equipment sets. And we're not sure exactly which standard is going to win out, but we definitely are very active members. In IPC, we're members in printed electronics standards, wearable standards. I think the little microphone has just dropped, so just to put that back up near your top, just so we get the sound feed. There we go. Yeah. Okay, so you've got a combination of different standards for your 3D printing, for example, and your 3D printing is coming online. So because we have all these different pieces of equipment in our 100+ sites, we have to be very cognizant of the costs associated with whatever we deploy. So we are actively going to the different standards development groups, appreciating what directions they're taking, and then hopefully coming to some consensus. This is much bigger than just one company. It's really an industry, several, many stakeholders, and we're really supportive of standards. We think that's really the lowest cost solution for everybody that wins.
Okay, so what about on your machine-to-machine software on your production lines? Do you have a system in place at the moment?
We do have different systems in place. I'm not at liberty to tell you which specific ones we have, but they're definitely not mainstream. I would say that in general, we have preferences. I mentioned that we have 5 different divisions. Each division is run by a specific COO. The COO gets to choose whatever they'd like. Recently, we established a committee internally where all the COOs are coming together as well as the CIOs. We're going to be meeting in April to discuss where we're going to go forward in terms of smart manufacturing. So all of this has happened over the last year. I mean, it was great to see what occurred at APEX, and it's basically snowballed internally. As you know, markets are changing, our customers are demanding. The time from ideation to deployment in a factory has gone from 18 months down to 3 months. Everything has been truncated, and so we need to have something sooner than later, and so our activity is actually going to increase.
So what you're saying is really you welcoming standards, because standards help you to make that happen quicker.
It does. Standards are by far, we saw it earlier, I don't want to go back in time, but when we were looking at semiconductor materials for printed electronics, it was only when a standard was developed in IEEE where you were measuring the time of flight and the mobility of a semiconductor before we went through, and that costs money to go and measure our semiconductor performance. If we had had a standard before we actually brought a material in-house, we could have said, what is the specification, what is the performance per the standard? In a lot of ways, standards reduce a significant amount of investment on companies such as ourselves and my colleagues here.
Okay, thank you. So, Oren, Menta seems to have taken if you like, a dual approach. You're participating alongside CFX, the Connected Factories Initiative. You're also pursuing a separate path with your OML. My question is, what are the strengths and weaknesses of that dual approach?
Sure. So it is important for me to stress out that we do fully support the IPC. We're participating. We have a number of individuals and quite senior individuals in the different committees, and we will continue to support the CFX standard. And just like Dan has just said, while we make a lot of money from the fact that there is no standard today, and we come and we try to bridge this, industry issue by reading all of the proprietary protocols and translating them, we still believe that we would benefit if there would be a standard. Because it's a big cost today to go and implement a system that gets data from the shop floor. And the value is really only once you've captured the data and you can do something in an application that you really provide value. Getting the data gives you no value. But today it's the biggest bottleneck and it's the biggest price. And if you go to somebody like Dan and says, there's going to cost you a couple of hundred of thousands just to get the data, well, there's no value in it. So we definitely believe there's a need for a standard, and it's very disappointing that unlike the semiconductor industry where 6Gem has evolved nicely, and you can't really sell a machine there if you don't have 6Gem. In our industry, every machine is different, and as Jason was saying, it's not only the data is different and transport protocol is different, so we definitely need the standard. The big question is, can IPC generate such a standard? We know that today all of the strongest de facto standards in the industry are not really owned by IPC. There's Gerber, which is not an IPC standard. Also ODB++, which Valor implemented 15 years ago, is really not an open standard. But these de facto standards are enough and are usually very successful. And that's why we decided at some point to maybe try to do something with OML, since as a private company we can do it faster, we can go faster, and we can try to enable it faster than trying to get a whole committee behind it and do that. So that was one of the reasons we went for that. The second one, and I think Dan touched upon it, is PCB assembly is just one small phase of building a product. Now, in CNC machines and in automation and robotics, there are industry standards which are out there which have been adopted. And when we go to the large OEMs, which build complete products, whether this is automotive, aerospace, they have these other standards running in the building next to PCB assembly. So in the CNC building, or where they do mechanical stuff, or where they do metal cutting, they have different standards, whether this is OPC UA or some other standards. And what they would really want at the end of the day is for the PCB assembly machines to behave the same way as a CNC machine or a metal cutting machine. I mean, why did this machine have to be so different? So I think a good standard for the industry would be one that taps into and complements these other protocols, uses the same standard way of communicating, and just maybe adding some events which are missing, then going and creating something completely new and completely specific for PCB assembly. And that's where we want to try to take over metal. So that's really our approach at the moment, and hope maybe I've...
But I mean, if CFX becomes a de facto standard...
We'll support it. We'll support it for sure, and it's going to be to our benefit, because if all of these machine vendors, we spend a hell of a lot of time developing drivers for all of the different vendors here, whether it's inspection, pick and place, reflow ovens, and of course that would allow us to really focus on the high-level applications. It will also benefit our competitors, as well as the ERP folks. So if there's one reason that ERPs haven't been able to really provide applications on the shop floor, is that they don't connect to the machines.
Yes.
So a good standard will allow them to do that, and you probably should expect that they'll go down and provide more, but then we can compete on who has the best application, who provides the highest value, and that's a fair way to compete, I think.
Oren makes a good point there, Jason. I mean, there's a lot of different systems that play into the making the factory work, the supply chain within the factory, if you like, more than just a line.
That's right.
So are you planning that CFX is going to go beyond?
This speaks to, like, for example, in our company, the majority now of our business is actually in discrete versus electronics, so our perspective is very much, we have 175 adapters for machines like they do. Right. And it's interesting listening to Oren, because we have absolutely the same perspective, is we can't add value with all these custom adapters to the machines, and they're always in flux, and there's always a conversation. Is it the machine? Is it our adapter? It's not good for the industry if we have a standard that goes away. But yes, in answer to the question, CFX is architected, as I mentioned with the Lego blocks, that by not being machine type centric, the capabilities can evolve into the discrete areas, and actually OPC UA, for example, is more of a connectivity than a data content. Right. So CFX could very easily extend and connect to those feeds from the discrete machines. It's critical because we can't build anything that's only around electronics, and I completely agree.
Yeah, that's good. That makes a lot of sense. So let's now I know we talked about this question before we started, but I want to look to see where the real value is for the smart factory and automation. There's a lot of people get confused. When you walk into a factory, they say, well, we've got 96% or 99% first pass yield, and so the management thinks, well, we're doing pretty well, but the real metric to look at is machine uptime. You go into factories all the time and machines are sitting idle. Numbers that come out of IPC are typically put this around 37%. So by optimizing equipment, machines, and communications, is this where the real money can be made out of this? That you can reduce the amount of machine downtime. Yeah.
My perspective is absolutely, because the way we look at it, let you identify, and if I could use an anecdote from a few years ago, it was in a beautiful factory with a glass executive office over the multiple lines. And the gentleman who ran the factory was looking at me, and I was looking out over the lines behind him, and he was very agitated that he had to expand his plant for capacity reasons. And he said, because I'm out of capacity, and I was looking across all these lines and every single lamp was red.
Right.
And I was thinking to myself, it's merely because those analytics, which he could spin around 180 degrees and look at the red, but he's not getting it through any meaningful analytics to know that if he solved the plant floor problem, he wouldn't have to expand the plant. And I see that happening everywhere. It's just that, I mean, it's a management axiom. If you don't have the right analytics, you don't know how to focus on your corrective actions. So I agree absolutely, but I see, if I could be more specific, I see these days, it used to be an obsession with group optimization, line optimization, and that's still there. But now the focus is shifting into the material logistics that surround the lines. All of that flow from even from incoming to the warehouse, to the local stores, the towers are so popular now. And that's all data-based, because that's a lot of individual moving parts that have to be optimized and controlled and monitored. So I do think that the connectivity is the foundation of even hoping to get to the point where that's being done properly.
Yeah, there's work needed to be done on that as well, on these incoming reels. There's so many different barcodes attached to them. You know, there should be some standardization where a barcode follows the reel throughout its life.
Well, you know, one thing that we see is definitely, you know, we go to factories and we try to implement the system, and one of the things that's missing is this unique reel ID. So still at the end of the day, you can put in a great MES system, you can get all the data, but still we see a lot of customers saying, well, we don't really use unique reel ID, and that's a big management change for them, having to label all of the different reels, understand the value of it. So that's one thing that's definitely missing. I would say from a utilization perspective, getting the data and understanding how you utilize the equipment is definitely the basics. But then you're going to ask, why is it so poor? Once you're going to get the real metrics, you're going to see, as Jason was saying, that you're not in an 85-90% OE, you're in a much lower. I think the other thing that OE is slightly misleading is it takes when the equipment is available. So you already deduct, for example, the fact that you're not running a third shift. But you should really measure that, because a machine could run overnight. The fact that you've chosen not to utilize it doesn't mean. So I think also, you know, we're kind of cheating ourselves there. We should take the full 24 hours that the machine can work and really see how many hours we're doing that. When you look at the airline industry, when they measure how long the aircraft is in air, they do it from a 24 hours. The fact that they can't take off after 10 because of a night ban and land before 5, they don't take excuses. They still say we're using this jet 14 hours out of the 24. We should do the same. The fact that you don't want to do a night shift, that's fine. Maybe you don't need, you can't, you have union, a lot of issues, but you should still measure that. And then when we start measuring, we'll see that the utilization isn't very good. And we'll go into definitely two things, as Jason was saying, material. Is it because material isn't running out, it's not getting there, it's being stolen by some other line, or is it because of lack of planning? I decided to do the product in two different lines, but I only have one stencil. I was going to move it from that line to the second line, thinking it's identical, but actually the AOI machine on this line is slightly different. I don't really have a program, or it's a revision. So then we're going to start seeing that our planning isn't that good, I think.
Right.
If I could extend that, I agree completely. We also see that because there isn't good connectivity to everything going on factory-wide, the knock-on effect of, the surface mount lines are feeding sub-assemblies for all intents and purposes into what are often complex upper levels. And the advanced planning systems, say from the machine vendors, is looking quite well these days at what's going on the surface mount lines, but they don't actually take the data into bottlenecks that are occurring in upper level marrying of the sub-assemblies. So you could be running full bore building sub-assemblies that have no hope of going into an upper level assembly when you could be using that line for something else that is available for going to the final fulfillment. Right.
Well, and again, that feeds into the previous question. We're talking about different systems that all need to really communicate better and optimize. Do you have a big problem with machine downtime at Jabil? Is it an issue that you work on? Is there a strategy to deal with it?
I think our issues are common throughout the industry. I think we're being more proactive. Our approach for smart manufacturing is really people, processes, equipment. We first educate the people, make sure the people know about design of experiments, understand how the different elements of the piece of equipment, what to look for. There's quite a bit of condition-based maintenance. We also are looking for predictive maintenance. So we're always improving. Quality is number one. We have several different lean initiatives within the company. So what we do is we basically find the problem and we deploy engineers to make sure that we find a solution. But I don't think that any one company or our competition has found a solution. I think we're all waiting for this wonderful utopia that has predictive analytics and that we have a digital thread that combines design, manufacturing, reliability, and this continuous improvement. But I think we're all kind of searching for a path forward, And it's good to work with these gentlemen because
Right.
we kind of are going after the same problem.
Right. It's interesting you mentioned this digital thread because I was in Japan 2 weeks ago and there was a keynote presentation by somebody from Cisco, and somebody asked the question, well, what should I be collecting? What data should I be looking for? And the simple answer is collect everything.
Yep.
Because you don't know in 3 years' time, in 5 years' time, you might think, well, I now need to measure, find out this information, but I haven't collected the data. So, the answer is if you can collect it, collect it.
Yeah. Internally, we now have an initiative called data science. So we have engineers that are going and becoming certified as data scientists, because our philosophy is, yes, we will be collecting all this data, but the question is, what is the value of the data? And so by educating several of, actually these are very large groups of individuals going through these courses, 8-week courses, they're learning about data science and understanding how to actually filter the data and go after the most important data.
That is the bottleneck, really, is that you collect all this data and actually turning it into meaningful or actionable.
Yes.
That is the bottleneck. But it's also a problem because there's a huge, it's a different skill set, really,
Yes.
and there is a skills gap in our industry. Sometimes, so there's quite a bit of education that's going to be needed.
This is just a program we started maybe a year ago, but we see that there's a lot of interest by individuals across the entire company. It's just not operations. We see HR is interested in this. We see the IP. Everybody sees the data's coming, but they want to understand what's the appropriate data.
Yeah. Makes a lot of sense.
I think Oren actually touched on that a bit about the data analytics, because everybody talks about machine communication, but that's not where the value is. And I think what you were alluding to is the value is companies like ours. If we could actually make that unbelievable mass of data useful without maybe the high-end engineering training, that has value.
So hopefully in 5 years we have a standard. Everybody's collecting massive amounts of data, and we sit here talking
Arguing
about what do we do with the
analytics.
data? How do we do it? It's just chunks, and then everybody, even if you have 2 lines, I'm going to bet you're going to be a big data, and then you're going to go to like the SAP HANAs or the Hadoop, and they're going to say this is millions of dollars, and you're not going to have the money to invest, and your challenge is going to do, what do you do with these massive amounts of data that I'm collecting all the time? And I know, what was the pressure in the nozzle picking up the component, and what was the temperature outside and the humidity and everything, and you have all of this data, and now how do you cross-analyze it? How do you do something with that? That's going to be probably the next challenge.
I agree.
But we're only going to deal with it after we solve the data connectivity. So that's definitely it's next.
It's totally a journey. So you collect all the data, and then you'll either use it for traceability further down the line, or you use it for some other optimization process. But I mean, currently we have obviously SBIs talking to printers. We have AOI, post-placement AOI talking to pick and place. Where do you see the next step going?
Well, this is a little forward-leaning because of the issues we've talked about, where we have a kind of a roadmap to get to these things. But I mean, really what everybody wants is that a certain degree of process improvement autonomy at the digital level, where the machines are taking context data from around them and actually obviously they can't make all the decisions on their own, but I think people would like them to make more closed-loop auto-correcting decisions. And I think that will keep going out across the lines, where it's bringing in, I know there's always kind of a fixation on the closed loop within a surface mount line, but there's a lot of process variables coming from post, even tests, so forth, that needs to also be taken into account in the earlier processes. So it's going to be about adaptive response.
Yeah, I mean, my personal view on it is we're at the beginning of the digitization thing, and we're working on the machine-to-machine communication at the moment, but it's eventually going to move into the materials.
Yep.
And when we get into materials, somebody's going to write the DNA roadmap of materials, so that you can work out all these different CT mismatches and things, and you're using an indium paste with a Henkel underfill, and you'll automatically know from your computer how compatible that is, what the compatibility percentage.
It's interesting. We already have made investments in algorithms that allow us to do something similar to that. Alignment of MEMS devices with laser diodes going through a lens. But we actually see a progression of more AI and deep learning type of algorithms implementation into our factories. we know it's not going to happen tomorrow, we know it's not going to happen next year, but we've made strategic investments to participate at universities as well as consortia to understand what is the next, because we think that's where the money is.
Yep.
And that, in terms of, that will make our factories the most efficient factories, and we'll be able to really grapple with some of the issues that we've had for 20 years and we haven't been able to solve.
Yeah.
So I think that some of the solutions today here that you see are very custom solutions. So you see a specific pick and place vendor going to a specific SPI vendor, and they do some kind of partnership, and they read some data, but it's a very bespoke solution, it's proprietary, it's connected. As long as you move slightly from maybe a different vendor or even a different model or a slightly different line, this won't work. Right. So today the solutions, while they're might be sexy or they might be compelling, they're not very stable, adaptable. And I think, until we have really some kind of standard that we can get the data and do this in an application where it's really agnostic to the machine and we can easily adapt it because we don't really care which SPI is there. I mean, the logic should be that it can work with any kind of SPI machine getting the data. Right. So I think the future is really in doing that. Yeah. The other thing I can say is, if we're talking about digitalization, and something that we see also from, Siemens, who have announced that they're going to be acquiring Mentor, they talk a lot about the digital twin and the digital shadow. So one thing that we see ourselves is really collecting all of this data, and think of it a little bit as somebody going to the hospital. He's got an empty medical record, and as they go through the different examination, the medical record starts to build up, and he's seen the regular doctor, then he gets an x-ray, he gets a CT scan, and it gets filled up. So we think about maybe the same thing with the PCB. As it enters the assembly line, it's empty, and as we start putting on paste and putting on components, subjecting to different inspection, we start building this digital twin or digital shadow with all of the information.
So this is going back to what Dan was saying about the artificial intelligence.
Exactly. And then you can go and run different kind of analysis on that and build some kind of smart algorithm that goes through that digital record and try to see, okay, you've done some material here which is unique with a specific process you haven't done in the past. Maybe we should subject this to additional testing or things like that you can do when you have this nice record of the build process fully digitalized.
Right. Excellent. Okay. So, one of the questions, obviously, when you start to work in an open platform, as you're suggesting, is it also opens up the potential risk to security. What's your view on that? What will you do to make the system also secure?
Well, if you recall, I was talking about the goal of CFX using a mainstream transport, the how it's moving the data around. The beauty of doing these mainstream, frankly, open source transports is they typically have built-in security. So the data is being encrypted inherently when it goes across. Because it is very important. Certainly right now, most of what we're talking about is intra-factory. So the IT security apparatus that's already there is pretty much, you could move unsecured data around the factory and be okay. But eventually people are going to want these pipes to go outside the factory of the data. And I believe that a transport has to be able to support security for even each individual packet that's going across of whatever standardized data comes out.
Absolutely. Because there's no doubt about it, the amount of hacking and industrial espionage is just increasing.
Especially when you start talking about controls, which CFX supports data and commands. Yeah. So if you hack into a command situation for machinery, you could
do some damage. Yeah. Okay. So I think we've pretty much come to more or less the end of our panel today. I think we've had some really interesting discussion and moved this argument along a little bit. Congratulations on taking it so far so quickly, Jason. I think that was one of the concerns of the industry, is that they wanted something, in place quickly.
But that would not have occurred without, I think it's upwards of 40.
I think the number of people that have been attending the meetings regarding this is synonymous with how important the industry regards it. I want to thank you all for joining me. Dan Gamota from Jabil, Oren Manor from Mentor, and of course Jason Spera, Chairman of the committee and
Co-chair, Co-chair.
Co-chair of the committee, there you go, and President of Aegis Software.
Thank you.
Thank you, gentlemen.
Thank you.